Okay, everybody turn to the first page, page number 2. This chart's kind of a quick recap of the greater than and the less than symbol, but what might be new. Raise your hand if you've ever seen that symbol before. Looks like this. I'll make it a little bigger so you can see it. Okay, so that's new, right? What is it? Do you know what that is, Abdullah? Right. It means that a number less than, and it says right here on the chart, less than or equal to, at most or no more than. You'll see it come into play how it works when we actually do it and use it. And then this one is greater than or equal to. Okay? Greater than. Just remember that for right now, and you'll see when we actually put it into play with actual problems, you'll see how it starts to make sense. Okay, so going back to what we've been doing all along, y plus 6 equals 16. Let's solve it with railroad tracks. What do I have to do to both sides? Minus 6, right? What cancels out on the left? What's left? And 16 take away 6 is? So y equals 10. So it's true for only one value, right? Only one number will make that statement true. 10. When we substitute it in, only one value will make this equation true, and that's for y equaling 10. Okay? Clear on that? There's no other values that's going to make the statement true. Because if I substitute it in, 10 plus 6 is 16. 9 plus 6 is not 16. And 11 plus 6 is not 16. Only 10 plus 6 is 16. So the only value that makes the equation true or balanced, remember we go back to an equation being like a scale, there's only one value that's going to make that true, and that's 10. Okay? Now, looks a little different, but it looks kind of the same, but it's a little different. Y plus 6 being greater than 16. We're going to solve it just like we would do normal train tracks. So make your train tracks, but they don't look like train tracks now because they have an inequality in between. Minus 6 on both sides. And what is 16 take away 6? Now, we got to think to ourselves, all the values that are greater than 10 will make the inequality true. So if I substitute this in, is 10 plus 6 greater than 16? No, it's not. They're equal, right? You would need a line under, but we haven't gotten to that yet. So what would have to be the value for y to make the statement true? Anything above 10. So would it work for 11? Would it work for 12? 13? All the way to infinity, right? Infinity symbol looks like this if you've ever done it. It's like a sideways 8, figure 8 sideways. So any value that's greater than 10 will make that inequality true. What about 9? Would 9 make it true? No. What about 10? About 11? About 16? What about 10.00000001? Okay, very good. So you get the concept. Almost the same, but now watch what happens. We have the little line under the greater than symbol, right? Right, still use railroad tracks. Take away your 6, and you get this. Any value greater than 10, but it can also equal it. So what's the only difference between this and this, Riley? And or equal to. So we'll work for 11, 12, 13, all the way to infinity. What about 10? Because it can equal it also. Okay? That's what we mean by it can be greater than or equal to that value. Okay? Inequalities, when you're given it looks just like an equation. The only difference will be there's not an equal sign separating the railroad tracks, but there'll be an inequality symbol. Solve it the same way. Go through the steps just like you've been doing. The only difference will be now that your value that makes the statement true isn't just going to be one value. It's going to be several values. Okay? So now turn to the first page. I'm sorry, page 3. Everybody do example 2 right now using your railroad tracks. I'll call somebody up. All right, how many have y g equals 5? So what's the only value that makes the statement true? Right. Okay, so part A, or letter A, we're going to solve it the same way. Divide both sides by, good, yes. G is less than 5. So for the purposes of the example, let's just stay with integers. Because any rational number will work, decimals and fractions also. But what integers make the statement true? Starting with the highest, I guess. I need values that are less than 5. Start with the highest. What's the highest value it could be? Right. Followed by 3. Go backwards. Followed by, followed by, followed by, and all the negative integers all the way to negative infinity. Would it work for 5? Who says yes? Who says no? Why no, Chris? Right, it's not. It doesn't have a little line underneath it, so it has to be less than 5, and it cannot be equal to 5. You'll see with this one though. So it will include 5. So when you have this now, less than means it has to be less than 5. Can't equal 5. So who can now give me the set of numbers for this one? Taylor. What's the highest it could be? Stay with integers though. Because yeah, 4.9 would, but and 4.9 would still not be the highest though. It would be for this one, but can this include 5? Right, because it has to be less than or equal to. It can be 5. Okay? So everybody now kind of get the gist of how the little line underneath the inequality works. Anybody have any questions on that? Okay, so why don't you guys just try page 4? Do page 4 only and then stop. I'll call you up to the board. Did everybody get for this after you go through your steps n being greater than 13? Okay, so now we take a look at the conditions and we answer yes, no, or true, false. If n is 15, would the statement be true? Right, because 15 is greater than 13. Riley, what about if n is 8? False or no? Either you could write either yes or true, no or false. What about 13 and a half? There's a rational number. Taylor. Melanie, what about negative 25? Okay? Okay, do the next one. Who wants to come up and do it? You have to wait. Matthew. Hold on, let me put it on pause so we don't have to waste extra time. All right, how many have x being any value that's less than or equal to 10? Or y, I'm sorry, y. So, would 5 work? Isn't 5 less than 10? Absolutely. Right? Be- right? Because 5 is definitely less than 10, so the answer is yes. What about 15? No, it looks like you might have a reverse, Matt. What about what about if y is 10? Yeah, because it has a line underneath it, so it's allowed to be equal to. And then negative 9. Okay, do 5 and 6, and then we'll go over it, but do not do 7 yet. All right, up to this point, show me with your hand, fist to 5. 5 means you totally get it. 1 means you totally lost. What we just did in part 1. 5 means you totally get inequalities and solving for them, and then middle would be around a 3. All right, so I see a lot of 4s and 5s, which is good. This part right here, the second part, okay, hands down. For whatever reason, students have difficulty with this, and I'm not sure why. All you have to remember, make a fist. Solid fist means that the number can equal that value. Ready? Make an open circle. That means that it cannot equal that number. Okay? Remember, closed fist means a closed circle or a closed dot. That means it can equal it. Open, open fist, or open circle means it cannot equal it. So watch. All I'm going to do for exercise 1, or number 1, is copy down what n was in the very first exercise. So if you go back to page 4, problem 1, it was n is greater than what? What was the answer? I'm just going to rewrite it. And now I'm going to show you how to graph it. What did I tell you? Closed fist means it can equal it. So closed fist, if you can make a little note on the side right here. Closed fist is a closed dot. Same thing if the inequality goes this way. Put it off to the side. It's like a little key for you to try to remember. Because students have difficulty remembering what's what. Open fist is an open circle. See, it's not colored in. Open fist. And there's no line under it. Means it cannot equal it. So if you can remember, the dot or open circle is your starting point, and then depending on which direction the inequality goes, determines which way the arrow is going to go. You'll see what I mean here in a minute. So the first thing I need to do is find 13 on my number line. Okay. Is it open fist or closed fist? Open, right? Because there's no line underneath it. So I find 13 on my number line, and I'm going to make a little circle right on the line. Not above it, not below it. See what I did there? Yes. Right. Whatever's on the other side of the inequality is the number is a starting point where you're going to put open circle or closed circle. Now I have to determine which direction my arrow is going to go. Which direction? We've learned this back when we did integers. Greater is which way, left or right? Right, everything greater than 13 is to the right. So will it work for 14? Does that make the statement true? What about 15? What about 16? 17? What about 7? What about 13 and a half? What about 13.1? What about 15.8? So everything to the right of my open circle, it would be true for. So I make a line following an arrow because the arrow is determining that it's every integer and rational number to infinity that's greater than, but not equal to, 13. Okay? Need somebody to look back and tell me what the inequality was for number 2. Number exercise 2. What was it on page? Go ahead. Y is less than, can it be equal to? Actually, I want to do it in red. I'm color coding it. All right, one more time, Sam. No, I needed a y was less than, what was it? Or equal to. Everybody agree? Concur? Yes? Is that correct? Without me flipping back? Okay, so find 10 on the number line. Open fist or closed fist, which is a closed circle at 10. Everybody in agreement? Now, everything that's less than 10 is which direction to the left would 9 make the inequality true? Would 8, 7, 13? What about 10.1? No. What about 9.9? What about 10? Yes, because it can equal it all the way to the end and make an arrow. All right, number 3 should have been y is less than 24. Should be. Anybody want to come in and do the coloring? Shannon. Open or close at 24? Okay, good. Thumbs up or thumbs down? Should be y is less than 24. Anybody agree or disagree? Can it equal 24? Is that showing less than 24? That's good. She's got it. Okay? She's got it. Somebody to come up and do number 4? Number 4 should have been x is greater than or equal to 15. Yes? Duels. It's going to be the last one for the blog. Open or closed at 15? Raise your hand if you agree. All right. Told ya. The closed circle definitely at 15, but it's greater than. Right. X is greater than or equal to 15. Don't make dots because you're implying that nothing in between would satisfy it to make it true. It's a line and make an arrow to imply that it's going on for infinity. Make an arrow. Make an arrow. There you go. All right, one more, number 5. M is less than 6. Serenity. Less than 6. Now, wait. Don't, when you do it right on the line. Trace the line. Not above it, not below it, but on it. Raise your hand if you got this. Okay, I'll let you guys work on your own, but listen. Listen, please. Still recording. Be careful when you get to negative numbers. Okay? Make sure you know that -1 is greater than -6.